What's up everyone, it's Mr. Lang. In this video, I'm going to take you through compound inequalities, the OR variety. There's and there's OR, but this video will just do OR. All you need is your notebook and a pencil. Let's get started. Alright, so I got a statement here. To see an R-rated movie, you must be at least 17 or be accompanied by an adult. So in other words, you could be like 15 years old, but go with your mom, and you'd be able to go into that R-rated movie. Or you could be like 25 years old, and you could go to that movie alone if you wanted to. Or you could be like me, be definitely older than 17, and take your mom to an R-rated movie, although that might be a little weird, but that would work too. So either this would have to be true, you must be at least 17, or you're accompanied by an adult, or both of them could be true, and you could still go to that R-rated movie. And if you understand that, then you're going to be fine with the mathy part of this video. So OR statements. In math, one or both statements are true for that OR statement to be true. So we're going to do some examples here with graphing OR. So the first example I have here is x equals 2 or x equals -1. Now a variable can't have two values. So in this case, actually, really only one of them could be true. But remember how we graph equality. It's going to be a closed circle. So it's either equal to 2, so I'll draw a closed circle there, or x is equal to -1. Okay? So that's actually no inequality there. That's just an equality, and we're done. Now we'll have a mix. We've got x is equal to -2. That's easy to do. Or x is greater than 0. So we know how to do that inequality. Greater than is going to be an open circle at 0. And since it's got to be greater than 0, we're going to draw the arrow this way. And that's it. That's how you graph. So when we have a mix there of an equality and an inequality, a lot of times it'll look something like this. Another example. X is less than or equal to -1, or x is greater than 3. Alright, so really what we're going to do is graph both of these separately. So we got x is less than or equal to -1, so that'll be a closed circle. Less than means we go left. X is greater than 3, that's going to be an open circle, and we're going to go to the right. And that's it. So we've got these two pointing away from each other. Either one of these could be true. Fourth example, x is greater than -5, or x is greater than or equal to 0. This is an interesting one. So let's do these separately. So x is greater than -5. So I'm going to do an open circle, and I'm going to go like this. I'm going to do this one in red. You'll see why in a second. X is greater than or equal to 0. Well, if I wanted to do this one, I'm going to do it above here. X is greater than or equal to 0. I'm going to go this way too. You notice we got this overlap. Really, this blue one here, the x is greater than -5, kind of dominates this one. It goes right through it. So in fact, this one's a little redundant. So what we're going to do is not even graph this red one here. We're not going to graph the x is greater than or equal to 0 because it's already taken care of with this one here. So really, if we wanted to simplify this, we don't even need this part of it. It would just be x is greater than -5. That doesn't even come into play. Alright? So if they're going in the same way, the arrows are pointing the same way with an OR, one's going to dominate the other, so you just take the one that dominates. Alright? Let's get into some examples. We're going to do 2 more examples, ones where we actually have to solve. Alright, so this is solving OR. Now we've got 2x minus 3 is greater than 1, or 10 is less than or equal to negative 5x. So when the variables aren't isolated like they were in the previous 4, all you have to do is solve them separately and then regraph them. So let's do this left side first. The 2x minus 3 is greater than 1. We know how to solve this. We're going to add 3 to both sides to start. Got to isolate that x. So we've got 2x is greater than 4. Then we're going to divide both sides by 2. 2's cancel out here. We don't have to flip any signs. We got x is greater than 2. Alright, so we got that side done. Now we're going to do this side. The 10 is less than or equal to negative 5x. So I'm going to divide both sides by negative 5. And whenever you divide by a negative, you know you have to flip. So this is going to be a negative 2 is less than or equal to, oh, I'm sorry, take that back, I got to flip, so I'm going to go greater than or equal to x. So I don't want to leave it like this. I want to kind of put down my solution here. So it's going to be x is greater than 2 or negative 2 is greater than or equal to x. And I like to circle this and put it nice and neat. Right? Now I'm going to graph this. And I don't have the number line all set to go here. So I just got to kind of number it in a way where I can get both of these on here. And they're pretty close, negative 2 and 2. So I guess I will just kind of put 0 here near the middle. And so we're going to have x is greater than 2, open circle, pointing this way. And we're going to have, if I say it like this, x is less than or equal to negative 2. It's opening away from the x. So it's going to go to the left. So this is a closed circle. And I'm going to go to the left. Most of the time, guys, when you have an OR, you're going to have the arrows pointing away from each other. I would say like 7 or 8 times out of 10. Alright, one more example. 3 halves x minus 5 is greater than 4, or x is less than 3. Alright, so let's solve this. I'm going to add 5 to both sides. It's just like 2 separate problems into one. So we got 3 halves x is greater than or equal to 4 plus 5 is 9. Multiply both sides. Oops. Let me try that again. By the reciprocal, 2/3. We're not going to flip because we don't have any negatives, so it's x is going to be greater than 9 times 2 is 18. 18 divided by 3 is 6. So we got x is greater than or equal to 6. And then this one's all done. So this is, or x is less than 3. And I can just circle it like that. So let's see how this looks. X is greater than or equal to 6 and 3. So listen, I'm going to start it here. We just need to be able to fit both on. Two, 1, and 0. It's exciting watching me do a number line. Alright, so x is greater than or equal to 6. That's going to be a closed circle. Greater than, telling me I'm going right. X is less than 3. It's going to be an open circle going this way. And there you go. Another example where the arrows are pointing away from each other, most common case. So let's get to the C of questions, the most important part here. I got 5 of these for you to solve and graph. And then I've got some questions up on Schoology that are related to this. Obviously, I can't have you input graphs, but there will be questions based off of the graphs that you do. So do a good job with those. Pause the video here, copy these down. You know what to do at this point. Thanks for listening.